Alright, today in class we looked at direct variation and we used the formula k equals y over x. And that's really all we needed to remember, because then we could substitute in values for y and for x. So I encouraged most of you, once I gave you the worksheet, to write up at the top of your paper, k equals y over, that's a terrible y over x. And k represents the constant of proportionality. So we were asked to determine in problem 1 if the following table shows proportionality. Well, in order to determine that, we need to solve for k for each of our sets of data. So k equals y over x. First we would come with k equals, my y value is 8. My x value is 1. 8 over 1 equals 8. For my second data point, I have k equals, my y value is 24. My x value is 3. 24 over 3 equals 8. So far we're in good shape. Both of them agree with each other. So it looks like our constant of proportionality is going to be 8. Let's keep going. K equals 35 over 5. Well, 35 divided by 5, that simplifies down to 7. Now we have a problem because we had 8, 8, and 7. Once I get to the point of finding out that I have a invalid solution, or sorry, not invalid, but a value that does not align with my other values, then I know that I no longer have a constant of proportionality that's going to apply to each set of data. So does this table show proportionality or direct variation? No, it does not. Number 7 asks for us to determine if the graphed function shows direct variation. Well, we had two criteria for direct variation. One, it had to be a straight line, and what we have does appear to be a straight line. And two, it had to go through the origin. Well, this has a point right on 0, 0, so it definitely goes through the origin. So, does the graph show direct variation? Yes, it does. Now the question also says, if so, find the equation. And so we've been working with the equation format. Y equals kx. So we need to find out what our constant of proportionality is. And we talked about in class how that is k equals y over x. So I'm going to find my value of my point here, which is 2, 1. And then I'm simply going to plug it into the equation. K equals, where do I want to write that? K equals y over x. My value for y, my value for x. So now that we know what k equals, we simply plug it into our equation of a line that we've been using in class. Y equals, instead of k, I'm now going to write its numerical value, so 1/2 x. That is our equation of the line. There we go. You were also asked to translate from each form. And so for problem 1, you were given an equation. And from that equation, we needed to determine the constant of proportionality, develop a table, and create a graph. And so we know right away that our equation is y equals k over x, or sorry, kx, and k represents our constant of proportionality. So in this problem, 2/3 is in the place of k, so k equals 2/3. Next, I need to create a table, and for me, the simplest way to create a table is to use my equation. So I'm going to create my little T-chart table with my X's and my Y's. And we want to go ahead and select a set of X's. So I'm just going to use 0, 1, 2, 3. And now for each X, I plug it into my equation. Instead of X, I will now have 0. So 0 times 2/3, well, we know that's 0. 1 times 2/3 for my next data point. Well, 1 times 2/3 is simply 2/3. Now we can plug in 2 for X. 2 times 2 is 4 over 3. Now we can plug in 3 for X. 3 times 2 is 6 over 3. Well, 6 over 3 reduces because we know that 3 will go into 6 2 times. So my solution is 2. And if you needed to go ahead and add lines to that chart so that you separated your data since we had some fractions, I'm quite okay with that. Well, now we get to the fun part. We need to create a graph. X's and Y's, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I know you probably can't make your graph perfectly proportional because we're not using graph paper here. But we should be able to get it somewhat close. Try to keep your spacing between each dash mark somewhat consistent so that your graph does look proportional when you're finally done with it. So, what we need to graph, well, I need 2 points. So if I look back at my data points, 0, 0 is going to be very easy to graph because that's the origin. And 3, 2 is going to be very easy to graph because those are whole numbers and they will be very easy to identify where their location is on the graph that uses the hash marks. So again, we're going to come back to our graph. We said 1 point at 0, 0 and 1 point at 3, 2. So 1, 2, 3 over, up 1, up 2. All I needed was 2 points in order to graph a line. So I now connect my line through the 2 points. That line goes on and on forever. And that's all this section was requiring of you. So now you should be able to fill in the rest of the remainder of the grids following this type of a process.